And then what did you do? You went in the back, you checked it in the index or the appendix or whatever, and said, yeah, I got the right answer, or no, I went wrong, here's where I went wrong. That was you doing cross-validation, right? So cross-validation is the process that a model goes through to teach itself. Okay? So when you hear things like that, what is cross-validation? Just give that type of answer, because that's the type of answer that your stakeholders are going to want. You may know about the folds and this and that, but your stakeholders don't care about that, right? So like when I ask that question in an interview, Joseph is giving pretty close to a model answer, right? Yeah, so really the only thing I would add to Joseph's answer is that it's the process that a model also goes through to train itself overall. It's basically how data science is achieved, right? Because you don't just you don't just say, well, here's a math formula, here's my data, go to it, right? Cross-validation is that process where all of that is mixed up. So I'm emphasizing that because that's why it caught my eye, right? It's the documentation you read on APIs is not always going to say how to train your model, right? They're going to call it by its proper name, which is cross-validation, right? And then, like I said, the second part that caught my attention was the hyperparameter part of it. And we're going to get to that, okay? So we're going to go ahead and click on the diagnostic section. And the diagnostic section tells us about the cross-validation processes and the different ways that we can use to train our algorithm, right? So it's telling us here how we can use it in Python. And then it's giving us a sample output. So I know that some of you have formal statistics training and others don't. But there's two columns here. Well, actually three columns. There's y hat, y hat lower, and y hat upper. Does anybody want to take a guess at what those are? And then you should also notice we have the Y column, right? But even if you don't have formal statistics training, you can probably take a rough guess at what these are. Okay, Patrick, you're quick on the answers today. Love it, my friend. Patrick says confidence intervals. All right. Anybody else? Or maybe you just agree with Patrick. You're welcome to just agree with somebody else's answer. Joseph says predicted value of that variable, I think. Yeah, that's one of these columns, but there's three columns, Joseph. Yeah, okay, yep, you're right. You've correctly identified y hat, right? So let's all agree, as Patrick and Joseph both pointed out, y hat is the prediction, right? And then Amina says maximum, minimum. Yeah, exactly. That's exactly right. Hamad, yeah, you got it too. Y hat is prediction. So you wouldn't know that unless you've had statistics training, because y hat and y hat lower, y hat is more from the world of statistics than data science strictly, right? And that's exactly what they are. More specifically, they're kind of like the inferential values of y. You know, if you want to get really academic about it, it's the inferential values of y, right? That's why it's the hat part of it, right? So y hat is basically telling us what the model thinks the answer is. And then y hat lower, y hat upper is basically the range that it thinks y hat should fall into. Or excuse me, what the range that y should fall into, not y hat. So Patrick, you're definitely on the right track. It's funny to say confidence intervals, because confidence intervals is what I would tell my stakeholders, because that, like, everybody kind of understands that. But a statistician might disagree with that, right? A statistician might tell you, well, it's really more of a range, right? So that's why I didn't give you an answer right away. But I think you're on the right track, Patrick, as far as what you would tell your stakeholders or how you would present this in a business meeting, right? It's basically the confidence interval that the algorithm is assigning. And then Y here represents our actual known value, right? So now, if you're able to compare Y hat to Y, well, now you're getting to a metric you can measure, right? That's that cross-validation part of it, right? That's the training part of it. Because now this is the algorithm saying, here's what I think the answer is. And then this is your, you know, your ground truth, right? Your ground truth is column Y. And now you have something to compare against. And you can say, whoa, wait a minute. Here, the algorithm thought the answer was 8.53, but ground truth is 7.92, right? So now we have like a measurable thing that we can use.